By the end of this lesson, you should be able to understand the basic concepts of data displays, work with frequency distributions, work with group distributions, construct and interpret a stem and leaf display, work with bar graphs, circle graphs, and line graphs. Reading and interpreting graphs. Okay, so after you conduct your survey, you can take your data and display it in various forms. One of the forms you can display it is line graphs. Line graphs shows change over a period of time. Another display is a bar graph, often used for comparisons. There's also a circle graph. Circle graph shows part of the whole. You can also use a stem and leaf plot, which is often used to find the mode and the medium of the data. You can use a line plot. A line plot shows the mode in a group. So a line plot is different from a line graph. A line plot is when you have a number line and you place the X vertically up and down according to how many of that particular category. You can also display your data using scatter plots, also known as scatter diagrams, and what that does is basically tells you if there's a trend or relationship between the two set of data. Let's start with bar graphs. So bar graphs are ideal for comparing two or more data. If you look at the example below here, we have a graph of the U.S. Antibiotic use. And we have categories, we have crops, pets, aquaculture, humans, livestock. So we're asked a question about what percent was used in livestock productions. So all you have to do is just look at the livestock bar and see how far it extends. And in terms of its number, notice that the x-axis is your estimated annual use in kilograms, 1,000. So livestock, notice it goes to 13,300. I'm sorry, 13,540 to be exact. So it says about what percentage was used in livestock. So we want to know how much it is that part of the whole. So what you're going to have to do is add up all your categories, the antibiotic use, and that's going to be on your bottom for your total. On top, you're going to have the part that you're looking for, which is the livestock, and that's 13,540. So if you have your calculators, go ahead and take your calculators out. You're going to go ahead and type in 13,540 divided by the total, 17,200. And what the calculator is going to give you is a decimal, and then all you need to do is just move 2 places to the right to turn it into a percent, and then you'll have the percentage for the livestock production. So what did you get? Okay, so if you did it correctly, you should have 0.787. Moving the decimal place over 2 places to the right, it's going to give you a percentage of 78.7%. If you round it to the nearest whole percent, that rounds to 79%. And there you have it. All right, so next we're going to discuss a circle graph, also known as a pie chart. Now, this is a graph that uses a circle to represent the total of all the categories, and it divides the circles into sectors or regions which look like pieces of a pie. And these regions or pieces show the size, the magnitude of each size of the category. The circle graph below that you see here shows a family's monthly expenses. And the angle around the entire circle, the whole circle, you know, is 360, 360%. But we want to focus our attention on the rent. The rent, notice, is 25% of the whole. And so if we want to know what is 25% of 360, well, anytime you want to know a certain percentage, for example, it says 25% of 360, we can do direct translation recall. If we turn 25% into a decimal, that's 0.25. Anytime you hear of, that means that you're multiplying. So 25% of 360 means to multiply 0.25 times 360. So go ahead and do that on your calculator, and let's see what you get. So if you type in 0.25 times 360, what you should get is 90. And so what that tells us is that rent would be 90% of that 360 angle. So if you have your protractor, you would move it to 90 degrees, and that is where you would sketch or draw just that sector of the rent. Because you know that it's 25% of the monthly expenses, all you have to do is 25% of 360, 0.25 times 360, which gives you 90. So you know to draw an angle that has 90 degrees, and that is what you would shade in for the rent portion. Okay, so, and you would just continue to do that for each one. For example, notice the next category, they spent about 30% in food. So what you would do is 0.30 times 360, and whatever number you get, that's your angle measure. So you get your protractor, you draw that angle measure, and then you would shade that, and that would be your food category and so forth. So when you're done with all your categories, again, it should equal up to 360 within that circle. Okay, when you get done with all your degrees, if you were to add up all your degrees, they should add up to 360. Here's another example. In this school survey, students showed these preferences for instructional materials. So in other words, they were asked which form of instruction that you prefer the most. So we had some that says they prefer to learn through computers, others written instruction, some said through TV, some said lecture, some said through film, and some said radio. So about how many students would you expect to prefer computers in a school of 750 students? So what we want to know then is, since computers, if you notice on the circle, computers represent 36% of the whole, 36% of that 360 circle. So what you want to know is, what is 36% of the 750 students? And that will give you the number of students who preferred computers. So again, take out your calculators, and all you have to do is type in 0.36 times 750. So go ahead and get your calculators out. I'll give you a minute. And tell me what you got. Well, let's see what you got. Okay, so typing in 0.36 times 750, enter. It should have given you 270 students. So that means that 270 students of that 750 total preferred computers as their form of instructions. The chart below shows the federal spending for 2011 till 2020. We are asked, what is the greatest single expense category? So looking there at the pie chart there, of all the expenses that you see, what is the greatest single expense? Well, all you have to do is just look and identify which piece has the greatest piece of the pie. So notice that the biggest slice of pie is green, the light green, which is the Medicare and the Medicaid expense. And that's about 35% of the total pie. So it says, what is the central angle? In other words, what is the degree of that category? So we know that it's about 35% of the whole. We don't know the degree. In order to find the degree, recall, we want to know what is 35% of 360. So you can find the degrees by simply taking the percentage and multiply it by 360, and that will give you the degrees. So go ahead and get your calculators out, and you're going to type 0.35 times 360, which is the total circle degrees, and that will give you the degree for that particular sliver or piece of the pie. Okay, so what'd you get? 0.35 times 360, what you should have got is 126. So therefore, that piece of the pie is 126 degrees. So if you were to sketch that, you would take your protractor out and just make sure that your angle measures 126 degrees. And now let's move to line graphs. Line graphs are used to depict change. So your points are used to represent data, and these points are connected with line segments. So if you see a line that is moving from left to right in an upward motion, meaning it's rising, that indicates it's an increase. And if you see that your line is moving from left to right in a downward motion, in other words, it's falling, that represents a decrease. The line graph shows the relationship between the time spent smoking a cigarette and pulse rate. The time, notice, is recorded along the horizontal axis in minutes, with 0 being the moment a smoker lights a cigarette. The pulse rate is recorded along the vertical axis in heartbeats per minute. Let's use this graph to answer a few questions. Question number 1. If the ordered pair x, y represents a point on the graph, what does x represent? Well, notice on the x-axis you have your time. So the x value represents the time in minutes. What does y represent? Your y value. Notice here the y-axis is the pulse rate in heartbeats per minute, and that is what your y value represents. Question number 2. What is the pulse rate 15 minutes after a cigarette is lit? So to find out what the pulse rate would be, we would need to first move to the x-axis where 15 minutes is, and then we're going to move up to where we touch the graph. So if we move up to the graph, and then to find at what point the y value would be, because we know that the x value is time, is 15 minutes. To find y, you need to go on the y-axis, and notice here that the value represented by y would be 80. So therefore, we would say that the pulse rate is 80 beats per minute, 15 minutes after a cigarette is lit. Question number 3. When is the pulse rate the lowest? So here in this question, we were asked when, which means it's about time. So we want to look at our x-axis, which is time, to see at what point in time was it the lowest. In other words, where the line reached its lowest point. And that would be at the very beginning. The line reached its lowest point from time-wise -5 all the way to 0. That was the lowest point of the graph. So recall that 0 meant that the moment the cigarette smoker lit up a cigarette. So -5, therefore, as far as time, would mean 5 minutes prior to that. So to answer the question, the lowest point of the graph is between -5 and 0, which means 5 minutes before lighting a cigarette. Question number 4. When does the pulse rate show the greatest change? Now, change can be an increase or decrease. It's a point in your line where you notice from left to right that it's moving upward, or from left to right moving downward. And the farther apart it is, the greater the change is. So when does the pulse rate show the greatest change? So if you look at all of your line segments on your graph, the portion that shows the greatest change, or where the line is the longest, would be between 0 and 5. So note, between 0 and 5 is where your line is the longest, which shows that between that period it showed the greatest change. And the fact that it is moving from left to right in an upward motion, it was an increase in that change. So to interpret that, when does the pulse rate show the greatest change? Recall, 0 means the moment they lit up the cigarette. So this change is between 0 and 5, which means 5 minutes after lighting the cigarette is when you saw the greatest change in the individual's pulse rate. Many businesses use line graphs to show profits and revenues. Here's an example of a real-world application. Now let's discuss double line graphs. Double line graphs compare patterns of change for 2 or more quantities. So here we have a double line graph that is showing the different types of medications or resistance of it. So we have the medication of Cipro, and then we have the is it cephalotrioxin? Yes. So I may be spelling these medications wrong, but let's call one Cipro and the other Ceph. So our question here is, In which years was the resistance to Cipro greater than the resistance to Cephro? So, in other words, we want to look for on the line graphs. Let's let the green represent the Cipro, and let's let A in blue represent the Cephra. So I want to know in which years was the green line, which is a Cipro, greater than the blue line. So you're looking on the double line graph to see at what point does the blue line, meaning this Cipro, that it was greater than the other medication. So let's look for all the points. So we see here, what was it at 1997? And we would say it's 97 because it's between 96 and 98. Also, at 1998, it's higher. And then the other point way over at the end, in 2011, it also shows a greater resistance than the Ceph. So that's 1997, 98, and 2011. Next question. Over this span, what was the highest resistance to Ceph? So the blue, in other words, what was its highest that it achieved and when did it occur? Okay, so we want to look for where the blue line, to the point where it is the highest, and then find out when did that occur. So all you have to do is look at its highest point, which notice here that the highest point looks like it is about 4.5, and it occurs at 2002 and 2003, looks like, yes. So about 4.5% in 2002 and 2003. So that's just simply looking at a double line graph, being able to interpret and answer questions based on that line graph. Scatter plots, also known as scatter diagrams, it's a graph of ordered pairs or pair data that shows the relationship between two variables. In other words, if you take points like you would on a rectangular coordinate system, you get all your data, you plot your points. Let's say you had a survey and you ask everyone, what's your favorite ice cream or your favorite color? And they tell you all the results. Then you take those results and you plot the points on a rectangular coordinate system or on a graph. You stand back and you look at these points and you're looking for what kind of trend, correlation of this data has. So if after you plot your points and you notice that you have a cluster of your points seemingly moving from left to right in an upward motion, that's called a positive trend or a positive correlation. If you notice that your cluster of dots are moving from left to right in a downward motion, that's called a negative trend or negative correlation. And then if you notice that your data is just kind of spread all over the place, like say we ask 100 people, when is your birthday? And then we plot that. And we notice that we don't see any cluster of data where it's all in one place. that they're just kind of all scattered all over the place, we call that no correlation or no relationship between that data. So again, for a positive relationship, what you're going to see is as you move along from left to right, as X increases, Y also increases. For a negative relationship or negative correlation, as you move from left to right, as X increases, Y decreases. In other words, the up and down, instead of going up, it's going down. So for a negative correlation, as X increases, Y decreases. And again, whenever there's no correlation or no relationship, your data is just spread out kind of all over the place. So in this particular example, we are asked to determine whether the graph shows a positive correlation, a negative correlation, or no correlation. Now, if there's a positive or negative correlation, I'd like for you to describe the correlation or the meaning. So here we see the relationship of the age of a car in years versus the value of the car. And we want to know what kind of relationship it shows. Well, if you take a look at the cluster of dots, notice that it is moving from left to right in a downward motion, which signifies that what is the correlation here of this graph? Yes, you got it. It's a negative correlation. And in terms of being able to read what the relationship of this data, you would say that as the age of the car in years increases, the value of the car decreases. So on the x-axis is your age of the car. Notice each year it goes up. The y-axis represents the value of how much your car is worth. And notice each year it goes down. So the relationship again is as the age of the car increases, the value of the car decreases. Let's take a look at the next example. We want to determine whether the graph shows a positive, negative, or no correlation, and if so, describe the correlation or the relationship. So notice you see the cluster of dots here from left to right is moving in an upward motion. And what type of correlation is that? Yes, you got it. That is a positive correlation. And how would you describe that correlation? Well, on the x-axis, that's what we start with first. The x-axis represents the hours spent studying. The y-axis represents the score on the final exam. So, the way you would read the relationship or describe it, you start with X and then you go Y. So we would say, as the hours spent studying increases, the score on the final exam increases. Again, as the hours spent studying increases, the score on the final exam increases. So whenever you have a positive relationship, you're going to notice that both for the X and the Y value, there's going to be an increase over time. So the more you spend studying, the higher the score on the final exam tends to be in general based on this study. In this last example, we're asked to determine whether the graph shows a positive or negative or no correlation. So here on the x-axis, it represents books borrowed from the library, and on the y-axis is the number of fines that you have for overdue books. So when asked over 100 people about the number of books they borrowed versus the fines that they had from the library, notice that the dots here, your pair data, your ordered pairs, are sort of scattered all over the place. There's no positive correlation here that you can determine. Neither is there a negative correlation that we can determine. Because they're scattered, there is no correlation between the relationship of the number of books that you borrow versus the fines that you have. So how would we describe, well, first of all, what kind of correlation here? There's no correlation or no relationship between these two variables. How would we describe? Now let's discuss stem and leaf plots. A stem and leaf plot represents data by separating each value into two parts. So you have the stem part, which is the leftmost digit, and then you have the leaf part, which is the rightmost digit. So here's some data of average chick weight in grams for 16 different species of birds. So we have 16 values here, and we're going to place those values into a stem and leaf plot. So when we do so, it's going to look like so. Notice here that on the leftmost digits, which is your tens place, that's called your stem. And the digits that is to the right is called your leaf. So starting at the beginning, and by the way, you should note that all your numbers should always be arranged from least to greatest, in other words, in increasing order. So notice here your first number started with 5 because you have a 0 in tens place and a 5 in ones place. That represents number 5. We also have number 6 and number 7. And notice those three numbers are part of our data. Second row, I have number 10. I have 2 11s because notice in our data we have 2 11s there, 3 12s, 13, 18, and 19. That third row represents our 20s. So starting with 20, so there's 2 for your 10s, 0 for your 1s. We have 20. We have 2 21s. And we have 25, all of which are values that are in our data. So let's answer a few questions based on this data. What is the lightest weight chick? So these values refer to the weight. So all we need to do is find the least value, and the least value would be at the very first or at the beginning of our leaf plot, and that's 0, 5. So the lightest chick would be 5 grams. Next question. How many chicks are less than 10 grams? So we want smaller than 10 grams, and that would be our first row here. We have the 5, 6, and 7 grams. So that's 3 that are less than 10 grams. And there you have it. Here is a stem and leaf plot for final scores for the last 16 games played by a local basketball team. So to construct a stem and leaf, which of the A, B, C, D shows the correct stem and leaf plot that represents the data? I'll give you some time to think about it before I reveal the answer. So take a look at them carefully. Recall for each number that the leftmost digit is your stem, the digit to the rightmost is your leaf. Okay, if you said B, then you are correct. B is the correct representation of the given data.